Hey there, Algebra 1. Today we are solving inequalities. What is an inequality, you might ask? Well, this is an equal sign, so it would be an equality. Oops, there we go. And then we've got I did that twice. Those are all inequalities. So first of all, let's consider the inequality x squared plus 4x is greater than or equal to 5. Let's sift through some possible values to assign to x that makes this inequality a true statement. Find at least 2 positive values that work and at least 2 negative values that work. So this is just a guess and check. Positive values that work. Let's try x equals 2. That means I would have 2 squared plus 4 times 2 is greater than or equal to 5. That is a true statement. Let's try x is equal to 1. 1 squared is 1 plus 4 times 1 is greater than or equal to 5. That is also a true statement. Let's try x equals negative 3. Negative 3 squared is 9. 4 times negative 3 is negative 12. Is that greater than or equal to 5? 9 minus 12 is a negative number, so no, that does not work. Let's try x equals negative 5. Negative 5 squared is 25. Minus 4 times negative 5 would be minus a 20. Is that greater than or equal to 5? Well, 25 minus 20 is 5. That is, in fact, greater than or equal to. Well, let's try x equals negative 7. Negative 7 squared. And then negative 7 times 4. Is that greater than or equal to 5? Yes, it is. Right? Okay, so basically any value bigger than or equal to 1 or less than or equal to negative 5 are going to work in that equation. Should your 4 values also be solutions to the inequality given here? Well, is that equal to this? Those seem equivalent. They are equivalent algebraic expressions. So yes, they should. Should your 4 values also be solutions to the inequality 4x plus x squared is greater than or equal to 5? Yes, because of the commutative property. Keep on going. Should your 4 values also be solutions to the inequality 4x plus x squared minus 6? See how that changed? Greater than or equal to negative 1. Well, all we did here, we went 4x minus x squared. That's the original one. We just subtracted 6 from both sides. We got 4x minus x squared minus 6 is greater than or equal to negative 1. So those are also equivalent algebraic expressions. Should your 4 values also be solutions to the inequality 12x plus 3x squared is greater than or equal to 15? What did we do here? We did have 4x plus x squared greater than or equal to 5. It looks like I just took both sides and multiplied, excuse me, and multiplied both sides by 3. If I distribute this through, I'd have 12x plus 3x squared and 15. Yes? Cool. Okay, that sort of warmed up our brains and it took a long time. So let's get moving into our lesson. Let's see, for this example, we're going to work through using addition and multiplication properties. So what is the solution set to the inequality? Express the solution set in words, set notation, and graphically. So I'm going to get all the letters on one side of the equal sign and the numbers on the other. So subtract 10 from both sides, and I have 5q is greater than 10. And then these two values are multiplied, so I need to divide to get rid of that. And so I have q is greater than 2. So set notation, q is real such that q is greater than 2. In words, q, is any value greater than 2. More than 2, bigger than 2, that's fine. And then graphically, I usually put 2 in the middle. That's a 0. This would be an open dot, and we are going to shade everything bigger than but not equal to 2. Okay, exercises 2 through 3. Find the solution set to each inequality. Express the solution set in set notation and graphically on the number line. I'm going to do the first, 2, and then I'm going to push pause, and you're going to try the next 3. This first one is sort of simple. I need to get that x all by itself, so I'm going to move that 4 away by subtracting 4 from both sides. So x is less than or equal to 3. So set notation, x is real such that x is less than or equal to 3. Graphically, I'm going to have 3 in the middle. Okay, close dot here to the left. B, I do not like that, so I want to get rid of it. Best way to get rid of that is to multiply every single thing in that equation by a 3. So if I distribute that 3 through, I'm going to have 3m over 3 plus 8 times 3 is 24 is not equal to 27. 3 over 3 is 1. Subtract 24 from both sides. I've got m is not equal to 27 minus 24 is 3. So there's my set notation. And graphically, I've got the 3 in the middle. I don't want 3 as part of the solution, but I need everything bigger than 3 and everything smaller than 3 shaded. All right, I'm going to push pause. You can try these. I'm going to give you a hint. You're going to get the right answers if you add or subtract to keep your variable positive. Okay, check back to make sure we got that right answer. Push pause. Now, pause. Pause. All right, there you go. Check those out. Push pause again and just look at the solutions and see if you got them all. Okay, if you didn't, star it and see if we can figure out why you didn't get it in class. All right, recall the discussion on all the strange ideas for what could be done to both sides of an equation. Let's explore some of the same issues here, but with inequalities. This is where we would multiply both sides by x, multiply both sides by x squared, etc. Sometimes we got more solutions, sometimes we got the same solutions. Recall in this lesson we have established that adding or subtracting and multiplying through by positive quantities does not change the solution set of an inequality. We made no comment about other operations. So let me highlight that. With inequalities, we are allowed to add, subtract, or multiply through by positive quantities without changing our inequalities. Those are the only things we're allowed to do. It's really special if we multiply through with negative quantities or divide with negative quantities. It changes our solution set, okay? So first of all, squaring. Do b is less than or equal to 6 and b squared is less than or equal to 36 have the same solution set. So if I First of all, look at this one. If I graphed it, 6 would be in the middle. I'd have a closed dot at 6 and shade everything smaller, right? If we look at b squared is less than or equal to 36, if b were 6, 6 squared is 36. That makes for a true statement. So 6 works. If b were negative 6, negative 6 squared is 36. So that works. If b were 5, trying to figure out a way to shade, that's 25. 25 is less than 36. b is negative 5. Negative 5 squared is 25, which is less than 36. How about b equals 7? 7 squared is 49, so that doesn't work. How about b is negative 7? Negative 7 squared is also 49. So I cannot shade anything here. I can not shade anything here. I can only shade in between. So that just means that these solutions are not the same. Right? Okay. Part B, multiplying through by a negative number. Do 5 minus c is greater than 2, and negative 5 plus c is greater than negative 2, have the same solution. So if you notice, this first equation right here, I just multiplied through by a negative number. Negative, negative. Let's see if they're the same. So let's solve for c. I'm going to subtract 5 from both sides. I've got negative c is greater than negative 3. Ooh. Okay, let's add 5 to both sides. Now I have c is greater than 3. Those are not the same. You may think that I just can go like this. C is greater than 3, but they're not the same solution. Okay? Let's look at this first one. C is greater than 3. So if I plug in a number greater than 3 into the equation, I would get, so greater than 3 would be 4. Is 5 minus 4 greater than 2? No. Okay, let's try it over here. C is greater than 3, so I'm trying it on this side. C is greater than 3, so 4 is greater than 3. Negative 5 plus 4, is that greater than negative 2? Negative 5 plus 4 is negative 1, is in fact greater than negative 2. So we don't get the same solution, okay? They are different. This is a big deal. All right, Bonzo, of course Bonzo, is ignoring exponents. Do y squared less than 5 squared and y less than 5 have the same solution set? I believe we just proved that with part A, that no, when both sides are squared, we introduce another solution, just like with the equalities of the last lesson. We introduce another solution. All right, so example 2, Jojo was asked to solve this equation for x. She answered as follows. 6x plus 12 less than 3x plus 6. She's going to factor out the greatest common factor by using the distributive property. And then she's just going to willy-nilly cross out the equations or multiply through by 1 over x plus 2. Okay, you can't do that. She figures like, oh, there's no solution. Well, if we take the original equation, Let's see. I'm going to go minus 3x. Minus 3x gives me 3x. And then sorry, I have some extra markings there. Minus 12 gives me 3x less than 6, negative 6. Divide by 3, x is less than negative 2. I do have a solution. Okay, you cannot just willy-nilly cross out variables by multiplying through by the variables. Multiplying through is dangerous. Okay, can't multiply through to cancel variables. That's dangerous, right? If you do that, you're going to lose one of your solutions. How about this one? Okay, this is a big deal. I've got negative q is greater than or equal to negative 7. Let's just do this. Let's add q to both sides. Hold on, let's do that correctly. Because you guys just want to multiply through by a negative 1, but I can't do that. I told you earlier that you get different solutions if you do that. So let's just go ahead and add q to both sides. I've got 0, q minus 7. So now I have q, oh not g, so sorry. Q less than or equal to 7. Okay, I don't like writing my inequalities like this. I really like my inequalities with my variable on the left. My arrow is pointing to the Q, or Pac-Man is eating the 7, so I need to keep it that way. So my answer is Q is less than or equal to 7. Well, I go back up over here and start over again, and I just, I don't know, multiply through by negative 1. Which would make this positive and this positive. If I just willy-nilly do that, now I have q is greater than or equal to 7. Okay, these are not the same, and that's a problem. There is a very, very special rule that says if you multiply or divide with a negative number, you must flip your inequality. You must flip it over. Inequality. Okay, you must flip your inequality. So right here, if I multiply through by a negative 1, I have to flip my inequality. That's how we make these equal, not unequal. All right, find the solution to each inequality. For this first one, I'm going to divide by negative 2. Divide by negative 2. I said if we do that, we have to flip our inequality. Okay, set notation and graphically. I'll do that at the end. Here, let's see. I've got negative x over 12 is less than or equal to 1/4. I think I'm going to multiply through by a negative 12 to get rid of those fractions. That's going to give me negative 12x over negative 12. I did negative, so I have to flip my inequality. Negative 12 over 4. I can simplify that now, and I have x is greater than or equal to negative 3. Okay, I'm going to do set notation and graphically and solve the last two. You push pause and do the same thing, okay? Push pause and solve them. Check your answers at the end. All right, there you go. Push pause again and check your answers. Please push pause and check your answers at this time. Don't move on until you understand if you made a mistake, why you made that mistake. It's super duper important. And then you can move on. Okay, let's try number 6. It says solve negative 4 plus 2t minus 14 minus 18t greater than negative 6 minus 100t for t in two different ways. first without ever multiplying through by a negative number, and then by first multiplying through by negative 1/2. So let's do the first way first. I'm going to collect like terms. Got a negative 4 and a negative 14, which is negative 18. Positive 2t, negative 18t, which would be a negative 16t. Negative 6 minus 100t. So if I don't want to multiply through by anything negative, I need to make sure that my variables stay positive. So that will help. Let's see, here I have 484t. Add 18 to both sides. And that gives me 24. Nope. 12. Divide both sides by 84, if I can write. And I get t equals, oh, it's not equals. Anyone catch that mistake? Greater than. T is greater than 12 over 84, which simplifies to, 1 over 7. Okay. Let's try it now by multiplying through by negative 1/2. So multiply through by negative 1/2. Negative 1/2. So that gives me negative 1/2 times negative 4 is positive 2. Negative 1/2 times positive 2 is negative 1. Negative 1/2 negative 14 is positive 7. Positive 9t, I just multiplied by a negative, so I need to flip that. Positive 3 and positive 50t. Now let's collect like terms. These two will give me an 8t, plus these two will give me 9. 3 plus 50t. I'm going to subtract this way, and I've got 42t. 6. So divide by 42. Divide by 42. T. Pac-Man's eating the t. 6 over 42, which is the same as 1 over 7. I got the same answer as long as I flipped my inequality. Solve this in two different ways. First, without ever multiplying through by a negative number, and then by multiplying through with negative 4. When you deal with fractions, try to get rid of them. I've got x over 4 and 1/2. I'm going to multiply through by a common 4. So negative 4x over 4 plus 32 less than 4 over 2. Simplify. Negative x plus 32 less than 2. Subtract 32 from both sides. I have a negative 30 and negative x. Multiply through by a negative 1. And I have x. Flip your inequality. 30. Now I'm going to multiply through by negative 4. Negative x over 4 plus 8 less than 1/2. Negative 4. That would give me a positive x over 4 minus 32. Flip your inequality. Negative 4 over 2. Sorry, this would be... Yep, I miswrote that. Cancel those out. That would be a negative 2. Oh, mistake. Mistake alert. Oh no, I did it. Flip my inequality. Add 30 to both sides. And I have x is greater than. Oh my goodness. Are you guys handling this? Is anybody getting a kick out of all the mistakes I'm making? Not good, right? Phew. Oh my goodness. 30. Same answer. And luckily, we are all done. Good job today.